All right, guys, we're going to graph sine and cosine here. I'll show you two examples. Excuse my voice, it's a little shot. All right, either example, okay? You're going to go about these the same exact way. First, you just need to know what the parent functions or what the parent graphs of both these look like, or more just so the table. So let's just think about sine of x, right? Where, what are my values of x and what's values of sine of x? And the same one I'm going to do for cosine. So x and cosine x. All right, so first off, 0, pi over 2, pi, 3 pi over 2, 2 pi, right? That's the same, right? Just going around the circle for both of these. All right, and the difference is where you start. Sine of 0 is 0, pi over 2 is 1, 0, negative 1, 0, okay? And then this one, cosine, you're starting on 1, pi over 2 is 0, negative 1, 0, and then back around to 1, right? And that's you just going around a unit circle. Okay, and that's me grabbing these coordinates here, going around. Right, this is the coordinate 1 comma 0, 0 comma 1, negative 1 comma 0, 0 comma negative 1. Remember, cosine is x goes with cosine, y goes with sine. Okay. Now, I know this is my function here for sine, so the first one I'm going to do is sine, okay? So all these values of sine are going to be manipulated. Okay, so if I have this function here, I'm going to take this. Okay, so I'll start with this one. Everything on the outside, meaning your negative 2 and your positive 5, are going to affect all your y values. So I'm going to take all my y values and multiply them by negative 2 and add 5, all the way down. Right, and I'm going to do the same thing over and over. Right, all the way down. So your a value and the d value, that's all you're doing to your y values. And this is going to give you all your new y values. Okay, so when I redo this, I'll make my new chart here. This is negative 2. Right, that's my new function. So 0 times negative 2 plus 5, 5, negative 2 plus 5, 3, 5, 2 plus 5, 7, and then 5 again. Okay, and now the x values. Okay, now the x values, this is going to affect my x values. So this one's going to be a little different. All I'm going to do is take each one of these, take 3x minus pi, and set it equal to each one of these x values. So slightly different here. So I'll do the first one on the bottom. So 1 is 3x minus pi equals 0. 1 is 3x equals pi. 1x equals pi over 3. So my first coordinate is pi over 3. Right, that's going to take into account my horizontal shift and my compression of 1/3. Okay, so this takes care of all your horizontal translation right to left, and it takes care of your horizontal stretch or shrink without even doing anything, right? Just taking it and setting it equal to 0. All right, so I did it again. So second time around, I'll go in pink here. 3x minus pi equal to pi over 2. 3x minus pi equals pi over 2. So I'm going to add pi to both sides. I got 3x equals. Okay, this is the same as writing 2 pi over 2 with a common denominator. So this is 3 pi over 2. And then dividing by 3, which is the same as multiplying by 1/3. And you get x equals pi over 2. So my next value is pi over 2. Now I can repeat this. I can repeat this process all the way down. Okay, and I could do it over and over again. There is a little shortcut here. All right, before I do this one, and I will do it just to confirm it. want to write these as one common denominator, just so I can see what's happening here. So the common denominator here is 6, right? And again, this is an optional, this step is optional. But this is to save the time of doing all the rest of this. All right, so this is really 2 pi over 6, which is pi over 3. And this is 3 pi over 6. So if you notice, I'm adding pi over 6 each time. So to get to the next one, I'm going to go from 3 pi over 6 to 4 pi over 6, 5 pi over 6, and then one more, 6 pi over 6. Right, and you need to do this 1, 2, 3, 4 times, right? Because we're doing that 4 times because we go around the circle. 1, 2, 3, 4 times, right? So it's 4 quarters in a circle, so that's why I gotta do that 4 times. And this is just 2 pi over 3 simplified. 5 pi over 6 doesn't simplify, and this is just pi. So these are the coordinates I need to graph my function. And just to make sure that this one matches up, right, I'm going to test this one down here. If I add pi to both sides, I get 2 pi. Then I divide by 3, and I get x equals 2 pi over 3, which matches up. Check. All right, so you go about doing this either way. You can set each one of these equal to each x value, and you'll get the right answer every time for your x values. So now when I go and graph this, so my original, sine looks like this, right? So sine looks like 2, 3, 4. Sine goes up, goes down. Right, this is my sine curve. Right, this is just sine of x. Right, and this is usually pi over 2, pi, 3 pi over 2, 2 pi. Right, that's usually what sine looks like. So I'm gonna just delete that for a second. So I'm gonna still keep all that. Okay. Except now, when I do this, my first coordinate I'm gonna start at pi over 3. Right, that's where I start. And that's what I'm getting from here, right? Pi over 3. And then I'm gonna go pi over 2, 2 pi over 3, 5 pi over 6, and pi. So I'm starting here. So start. Okay, I'm going to consider my y values are 5, 3, 5, 7, 5. So 1, 2, 3, 4, 5, 6, 7. My midline is 5. 1, 2, 3, 4, 5. So there's my midline, right? Just control. There's my mid. And remember, because it's sine, starts on the midline. So I'm going to start on the midline. So pi over 3, 5. That's my start. Okay, from here, I'm going, it's negative sign, so it's going down. So I'm going to go down to 3. Put my pi over 2, 3. Then at 2 pi over 3, I go back to 5. 5 pi over 6, I go up to 7. And then at pi, I go back to my midline. And this will go on forever, right? So in a sense, you don't have to worry about what all the transformations are. Sure, you could do reflection over the x-axis, vertical stretch, or horizontal compression by 1/3. This one's going to be, you have to factor this out so you can see the transformation. Shift, right pi over 3, and then up 5. Yes, you could get all the transformations that way, but if you use this technique everything here under technique-wise to get the coordinates, you don't actually have to worry about the transformations. You got your new coordinates down here, right? And that's all you've done. Let's do one more. Let's take sine and cosine here. Drag it down here. We don't need sine on this one. Okay, so same thing's going to happen here. Okay, so again, that's just going to affect your y values. Piece of cake. Multiply everything by 1/2 and subtract 3 all the way down. Right, this will take care of your vertical shift, your vertical stretch of 1/2, and your midline. Nothing more to do than that. Right? Just multiply and subtract. All right, and again, the one that's going to be more challenging is the x values. So all I'm going to do is just take this whole argument here, and so I'm going to say 1/2 x plus pi over 2 is going to equal 0. So I'm going to do that down here. So 1 is 1/2 x plus pi over 2 equals 0. So I'm going to subtract 1 pi over 2 on both sides. So I get 1/2 x equals negative pi over 2. And then I'm going to multiply by 2 on both sides. That goes away. X equals negative pi. Okay, so there's my start. Right, this tells you your horizontal shift. You're starting horizontal. Your transformations are horizontal shift left pi units. Great, cool. I'm going to do one more, and then I'm going to use the shortcut again. So here I'm going to do, again, 1/2 x plus pi over 2 equals pi over 2. So 1 is 1/2 x plus pi over 2 equal pi over 2. Remember, all this is just coming from here. And the rest of these coordinates, and all these are just coming from here, right? All right, I'm going to subtract pi over 2 from both sides. I get 1/2 x equals 0. And then I'm going to multiply by 2, and I get x equals 0. Cool. So when I make my new xy axis here, when I have x and then this cosine is 1/2 cosine 1/2 x plus pi over 2 minus 3. Okay, well I got my y values here, so 1/2. So it's 1 times 1/2, which is 1/2. 1/2 minus 3 is negative 2.5. And then 1/2 times 0 is 0, and then negative 3. And then it's negative 1/2, and this is negative 3.5. And then 0, and then negative 3. And this one should go back to the beginning, negative 2.5, right? This goes fully around the circle. Right, your start and your end should match, right? These two should match, because now you just went all the way around the circle here. Okay. All right, so my x value. So my first x value is negative pi. And then my next x value is 0. Well, how do I get from negative pi to 0? Well, I add pi. Well, I'm going to keep doing that 4 times. So plus pi, plus pi, plus pi, and plus pi. Right, so 1, 2, 3, 4. Remember, let's go completely around the circle. Right, so where I start is negative pi. How I get from negative pi to my next coordinate is adding pi units, and then I keep doing that 4 times. Okay. You could also verify one more thing too. Your b value is 1/2, and your period is equal to 2 pi over b. So your period is equal to 2 pi over 1/2, which is just 4 pi. And if you notice, you notice your period is 4 pi. Right, so you start and you finish at 4 pi. So 1, 2, 3, 4 pi. All right, and then if I'm graphing this, bring this line up a little bit. Okay, so I got negative 1, negative 2, negative 3, negative 4. Okay, and I'm going to start at negative pi, 0, pi, 2 pi, 3 pi, 4 pi. I'm going to stop at 4 pi. So again, it's 1, 2. So did I go too far? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oops, sorry. I went too far in this one. I did one too many. So 1 pi, 2 pi. Okay, so 1 pi, 2 pi, 3 pi, 4 pi. Okay, and there's my period. Okay, so again, my period is 1 pi, 2 pi, 3 pi, 4 pi. And that matches my period here. Okay, so I'm only going to 3 pi here, sorry. Okay, and all the rest is 0, pi, 2 pi. Alright, so my midline is -3. My amplitude is only 1/2, so it's cosine. Cosine doesn't start on the midline, it either starts above or below. Since it's positive, it should start above, and it does. It starts here, -2.5, check. So, negative pi, -2.5. 0, -3. Pi, -3.5. 2 pi, -3. And 3 pi, -2.5. And there's my cosine. Alright, so you could really use this technique for any graph you've graphed in Algebra 1, Algebra 2, and so on, okay? All you need to know is what the parent function is, and then you go from there, okay? So just hypothetically, this is y equals 3 times the square root of 2x minus 7 plus 5. As long as you know the parent function of, or some coordinates of the parent function, so 0, 1, 4, 9, if you remember this, so 0, 1, 2, 3, right? This is the square root function, square root of x. Then all you would just do is multiply your y values by, right? Your y values get multiplied by 3 and 5. So times 3 plus 5. And your x values, you just set them equal to the inside. 2x minus 7 equals this. 2x minus 7 equals this. And you solve it all the way through. All right? And sometimes you're able to see the pattern and you could just add as you go. But sometimes that doesn't happen. But otherwise, this technique works for every single graph. And then get you new coordinates. All right, hopefully this is helpful. See you in class the next time.